Okay, so in this video, we're actually looking at interpreting box plots, and really this is what the exam questions are all about. Okay, so drawing box plots is useful because that's kind of usually the first part of a question, but they often ask you to compare two data sets, often two box plots, like I've got here, or something similar, which you can see on the second. So I've got one example with a U-try, but basically, right, we're looking at comparing box plots. And important to note with these questions here, really, when you're comparing data from box plots, they're really asking you to compare kind of three things really, or one of three things. Either the median, right? So you can get the median from two sets of data, and the median is a measure of average. A bit like the mean is also a measure of average. Median is a measure of average. Okay, so you might say in context, and these questions are all about context. If one median is bigger than the other median, you might say on average set A had a bigger median, so on average whatever you're looking at could be heights are bigger, for example. So that's really important, right? Median is a measure of average. That's a really key word to understand. Or you could also compare with box plots something called the interquartile range, which we saw last video when drawing box plots. And interquartile range, right, it's in the name there, range, is a measure of spread. Okay, so if one data set has got a bigger interquartile range, then the spread is going to be bigger. Okay, and spread, you can also kind of call it as being how varied something is. So these are really key words when we describe box plots. Okay, as you'll see in a second, right, because you'll see in a second, we'll put these words into context, which is really important. And the last one that you could really compare with a box plot is the range of your data set, which is similarly to the interquartile range, right? Range is also a measure of spread. Okay, it's just measuring the biggest to the smallest value, whereas the interquartile range is the sort of upper quartile, so this bit here, to the lower quartile, this bit here, which is a little bit different, but it's still a measure of spread. Okay, so let's also write that in. So spread, or how varied something is. Okay, so really when you're comparing box plots, you're looking out for these three things here. Okay, so let's get into it. Right, example one, and then you can try the second one yourself if you wish, or watch me go through it. Example one, right. Here are the times in seconds that 15 people waited to be served at Rosa's Garden Centre. Okay, and are they in ascending order? Yes, they are. Biggest to smallest, which is useful. On the grid, draw a box plot to show this information. So from last video, we should be pretty good at this, hopefully. We're just got to go and put this as a box plot. So the minimum value is that 5. Let's go and draw that on our diagram. So these are going up in increments of 1. So it's just going to be, it's quite small on my screen. You know what, let's zoom in actually. Let's zoom in. There we go, nice. And that's good. And hopefully I can move this around a bit more. Okay, good. A bit more zoom in. Good, 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 good. Okay, hopefully that is clear. Good. So the smallest value is 5. So that's going to be, it's going to be quite tricky on my screen, but right. I'm going to go and draw it in like this. There we go. That's 5. The max value is 44, which is going to be, that's 45. 44 is going to be here, and there we go. So that's my biggest value. Right, the median, I've got to go and cross out some values now. So first value, next in, smallest, biggest, smallest, biggest, and we keep going until we get to the middle value. Let's keep going, good, 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 and good. And this one works out nicely, right? The middle value is that 25 there. Let's go and draw that one in, and it's going to be a bigger line this time, which is really important. 25 is there, and let's make it just clearly much bigger. There we go. That is our median, and let's write that in. So that is the median. You don't need to write this in, the median bit, but just so to make it clear for you guys, hopefully. And then I've got to go and get my lower quartile and my upper quartile. So I've got to go and really compare now. My lower quartile, I've got to look at my lower half of my data, and then cross off my values again. So start from here, cross it off, and we work inwards. We're trying to find the quarterth value here, which works out nicely. Okay, that is going to be 14. So that is literally my 1/4th value along. So 14, let's go and draw that in. 14, which is going to be a bit hard to see on this, but 14 is going to be there. Okay, let's write it in. So that was 14. Ooh, let's undo those two. Undo again. So the lower quartile, sorry, is 14. Median was 25. And we've got to find the upper quartile still. Let's go and do that. So let's go and make this pen again. And we're now looking at this part of our data for the upper quartile, like the upper half. And let's go again from the end to the start, end to the start, end to the start. And there we go. Right, your upper quartile is 30. So let's go and draw that in. So 30 is going to be here, isn't it? There we go. Perfect. Okay. And, oh no, is that on 30? It's not. Sorry, that was pretty silly. Right, 30 is here, isn't it? Sorry. There we go. So 30 is there. And then we just go and join all up together. There we go. There we go. And there we go. So on screen, it's not that easy to do, but hopefully it is about as accurate as I can get it. Okay. And that is good. So that is the first part. I believe it is done. Okay, let's just make it really clear for you guys. So we're just saying that this value here, that is your upper quartile, UQ, which we said was 30. The lower quartile is 14. Your minimum value is down here. Min value, which was 5, which is here. And your maximum value is there, which is 44. Okay, that's a bit extra. All you need to do is draw in the actual box plot. That is fine to get the marks there. Okay, good. Right, part B is over here. Let's get this clear on the screen for you guys. There we go. So what is part B saying? Part B is saying, right, the box plot below shows the distribution of times that people waited to be served at Green's Garden Centre. So it's just looking at a different restaurant this time. Compare the distribution of the times that people waited at Rose's Garden to the distribution of times people waited at Green's Garden. Right, a very typical exam question. And this is going to probably be a 2-mark question. So really, we need 2 points there. Okay, so it's 2 is going to be absolutely fine. So let's go and compare. Right, let's go and compare the medians to begin with. Right, so let's do that. Compare the medians to begin with. So basically, right, choose any 2 of either the median, IQR, or the range. Usually I go for the median and IQR, and then you've got to put it into context. So we can say that the median waiting time for Rose's Garden Centre is 25, which is here, and the median here looks like it's 21, which is lower. So we can say something like, right, the median, excuse my handwriting, I'm not very good at writing words, I'm a bit messy, but the median waiting time is greater at Rose's Cafe. I'm just going to put Rose in short. At Rose's Garden Centre. And then you've got to state the value, make it really clear to the examiner, which is 25. Okay. So it's 25, which is bigger than Green's, which is 21, which is bigger than Green's, which is 21. So what does that really mean in terms of the question? It means, on average, there was a higher waiting time at Rose's. So because the median is bigger, and median is a measure of average, like we said, so we can say, so on average, there is a longer waiting time at Rose's. Okay, so what I've done there is, which is really important, I've stated the values, 25 and 21. I've said it's the median, and I've interpreted it in terms of the question. The median is a measure of average, so I've said on average, longer waiting times at Rose's, and that is a great answer. Okay, that's 1 mark. For the second mark, I've got to go and compare something else. Let's go and compare the interquartile range, because that's quite a nice one to do. So let's go and compare the interquartile range now over here. Well, the interquartile range from this diagram is going to be, well, the upper quartile, so the IQR over here, interquartile range is equal to 30, take away 14, which is equal to 16, and that is for Rose's Garden Centre. And then let's look at the interquartile range for the Greens. Well, the upper quartile here I can see is 35, it looks like, 35. So 35 is your upper quartile, take away your lower quartile, which is this one here, which looks like it's 11, 12. So 35 take away 12 is equal to 23, which is equal to 23. Okay, so what are we saying here? We are saying that because this time the interquartile range, the spread, and that's right, let's make sure we can see that is equal for greens is place. Well, because the interquartile range is lower at the rose garden centre, the waiting times are less varied. So we can say the waiting times at roses, at rose, I'm not going to put a garden centre, but roses is pretty clear hopefully, is less varied, and that's the key word there, less varied, because the interquartile range, IQR, is smaller than greens. Okay, so we said, and we're going to state the numbers here, we can say that 16 is less than 23. So these are really good answers, right? Because the median, I talked about the key words here. So we talked about, right, the median. Oh, let's make that a different color. Right, the median. So I've stated the key measure of average there. I've stated the numbers. So I've got 25 and 21. So I'm talking about, you know, I put it into context. On average, it is longer than there. And for the IQR, the key words here, I've got less varied because I'm referring to the interquartile range, and I've stated the numbers, which are down here. So that is a really good answer. Okay, so you can try this one here yourself, and it's similar, but right, before you kind of get into it, you don't need to draw a box plot for this information down here. You've just got to be able to pluck out either the median, the interquartile range, or the range when you compare the data. And I should really say, probably, this is going to be, again, a 2-mark question. So when you go and compare the distribution of data, you just need to compare 2 different points, and that's going to be enough. Okay, so pause the video, give this one a go if you want to, and we can work through it with me. Okay, the you try, right, so Tom recorded the times in seconds some boys took to compete on an obstacle course, and he drew a box plot for his results. So this is, okay, one set of data. Tom also recorded the times of girls took to complete the obstacle course, right, so this one is for boys, and this one is for girls, okay? And here are the times for the girls, and notice, right, they are in order, which is really useful. Okay, so we can go straight into crossing off our points in a second. Compare the distribution. Right, I'm going to go and compare again to begin with the median. That's always a good one to begin with. Right, so the median is the middle value. So for the boys, that's going to write it over here. So the median for the boys is equal to, we're looking at this value here. That's 110. We're going up in increments of 1, 11. It's quite hard to see. I think it's 15. 115. Yeah. Boys is 115. And for the girls, I've got to go and cross off my data. So that's going to do that. So from the start to the end, start, end, start, end, start, end. Just be careful with this. Start, end, start, end. Okay, so it works out nicely again. I've got my 112 is the median for the girls, which means on average, right, girls took less time to complete the obstacle course because the median is a measure of average again. Right, median is a measure of average. So we can say, right, I've got to put it into context, on average, the girls took less time to complete the obstacle course because the median, because remember median is your measure of average, the median is less, and I've got to state my numbers, which is 112 is less than 115. So right, again, importantly, I've talked about on average, because I'm talking about the median, and I've stated the numbers 112 and 115. Those are the keywords there. So good, if you got that one there. Let's now go and compare. I like to go for the interquartile range. Instead of the range, I don't know why, I just prefer going for the IQR. Interquartile range. So let's go and do that one now. And remember, interquartile range, similar to the range, right, is a measure of spread, how varied your data is. So for the boys, right, the upper quartile, so the UQ, is equal to 120, and the lower quartile up here, LQ, is equal to 111, 12, 113, I think. Yeah, 113. So for the boys, the interquartile range is your upper quartile, take away your lower quartile, which is 120, take away 113, which is equal to 7. So for the boys, the IQR is equal to 7. Now for the girls, we've just got to go and work through our data again. Let's go and look at, so this here is our lower half of the data. So we've got to go and cross off from start. Let's make it thicker so we can see what's going on. So from the start, end, start, end, start, end, start, end. Okay, so the lower quartile for the girls is 108, and then for the upper quartile, similarly, we go and compare our upper half of the data to find the kind of the third quarter value. So we go from our lowest to top, lowest, top, lowest, top, lowest, top, and there we go. Right, the upper quartile is 117. So the interquartile range for the girls is going to be equal to 117 take away 108. Okay, 117 take away 108 is 9. Take away 108 is 9. Okay, so that's equal to 9. So for the girls, the interquartile range is 9. So this time, right, the girls have a bigger interquartile range, which means that the time taken to complete the obstacle course is more varied. Okay, because remember, IQR is a measure of spread. So I can say here, the time taken for girls to complete the obstacle course is more varied. Because the interquartile range is bigger than the boys. Okay, and we've got to state the values. We're saying that 9 is greater than 7. So there we go. Right, again, I put it into context. I said that the time taken for girls to complete the course is more varied because we're looking at interquartile range. That's the key words there. And I've given the values of 9 and 7. So really, right, these questions are really important. We've got to put things into context. Okay, so either you talk about the median, interquartile range, or the range. Usually it's only 2 points. They're usually 2-mark questions. I like to go for the median and the interquartile range, but you've got to put it into context. You've actually got to, context meaning what's the question talking about. So here they're talking about the time to complete the obstacle courses. Okay, hopefully that was useful and you can actually read my handwriting. I think it should be okay. You can see the rough points, hopefully. But that is box plots completed. Thank you.